Hi everyone. Here we have another question on the topic sequences of numbers. And this question is under the subtopic geometric progression. Three consecutive terms of a geometric progression, GP, are 5x plus 4, 4x minus 4, and x plus 2, where x is an integer. We are asked to find A, the value of x, B, the common ratio, and then the equation continues. Given that the fourth term of the progression is 3, find the first term. And D, the last part, find the sum to infinity of that geometric progression. We have here a GP. We know the characteristics of a geometric progression. A geometric progression must have what we call a common ratio. Here we are given three consecutive terms. I want to remark here that what the question says is that this, and this are three consecutive terms and not the first three terms. So we don't make the error to call this the first term, second term, third term. No, they are just three consecutive terms in that geometric progression. Okay, so we have three consecutive terms are 5x plus 4, 4x minus 4, and x plus 2. So we can put them like that. These are three consecutive terms. We know the characteristics of a geometric progression. A term higher placed divided by the term just before it will give us what we call the common ratio. And the common ratio is the same throughout a geometric progression. So if we have three consecutive terms, so it will mean that if we take this term is higher than this, if we take this term divided by this, we are going to have the common ratio, which is the same value as when we take this term divided by this term. And so let's exploit that property of geometric progression. All right. These are three consecutive terms of our GP. It therefore means that this term divided by the term preceding it will give us the same value as this term divided by the term preceding it. And that value is what we call the common ratio. Now let's take this part. All right, when we cross multiply, we'll have x plus 2 into 5x plus 4 is equal to 4x minus 4 squared. Look at it. So let's open up the parentheses. X multiplied to 5 is 5x squared. X multiplied to 4 is 4x. 2 multiplied to 5x is 10x. 2 multiplied to 4 is 8. And then let's open up this other one. We have 4x minus 4 all squared. It means 4x minus 4, 4x minus 4. Okay, so this one will give us, all right, let's just write this one up there since we need to fill out the result here. 4x minus 4 squared simply means 4x minus 4 multiplied to itself. 4x multiplied to 4x is 16x squared. 4x multiplied to negative 4 is negative 16x. Negative 4 multiplied to 4x, negative 16x. Negative 4 multiplied to negative 4, positive 16. So we have this quadratic expression here equal to this quadratic expression. Let's first of all handle these like terms that are there. So this means we have 5x squared, 4x plus 10x, 14x plus 8 is equal to 16x squared. Negative 16x minus 16x gives us negative 32x plus 16. All right. When we have a quadratic expression equal to another quadratic expression, to solve for the variable x is always wise to take everything to one side and then have 0 on the other side. So if we look, it will be preferable to take everything from the left hand side to the right hand side, because I see 16x squared and this is just 5x squared. It's easier to work with 16 minus 5 than 5 minus 16. So I prefer to take everything from the left hand side to the right hand side. That way I have 0 here. So I come over here, it will be 16x squared minus 5x squared. Alright, for the x squared, then we'll now take for the x terms. We have negative 32x plus 14x going that way becomes negative 14x. Then we'll now take the constants. This is 16 here minus 8. Alright, so we have 0. 16x squared minus 5x squared is simply 11x squared. Negative 32x minus 14x, it gives us negative 46x. And then 16 minus 8 simply gives us 8. So this is the quadratic equation we have to solve for x. Remember our first question here. Question A says we should solve for the value of x. So this is what we are doing. We need to solve for x in this quadratic equation. So if we prefer the quadratic formula, which is the best here for now, so we know our A is 11, our B is negative 46, and our C is 8. And the quadratic formula says x equals negative b plus minus the root of b squared minus 4ac, all of that divided by 2a. So let's put in the values that we have. So that's going to give us negative 46 plus minus the root of negative 46 squared minus 4, our A is 11, and our C is 8, 4AC. All of that divided by 2A. So negative gives us positive, so we have 46 plus minus the square root. Negative 46 squared is 2116. 2116 minus 4 times 11 is 44 times 8 is 352. All of that divided by 22. 2 times 11 is 22. So we have 46 plus minus the root of 1764 all over 22. So that gives us this root here. This root here will be the square root of 1764 is 42. Alright? The square root of 1764 is 42. So we have 46 plus minus 42 all over 22. Alright? So that we can have x, and we take the positive. Let's continue up. So we have x equals 46 plus minus 42 all over 22. Alright, so when we take the positive, x will be equal to 46 plus 42 all over 22. That should give us 88 all over 22, which is simply 4. Or x is equal to 46 minus 42 all over 22. 46 minus 42 is 4 all over 22, which simplifies to 2 all over 11. Okay, so pay attention. All right, Mr. Bennett, we're told that x is an integer. What is an integer? Integers are positive or negative whole numbers. Positive or negative whole numbers. That means no fractions. Let's see here. Our second choice for x is a fraction. And we are told that x must be a whole number. It therefore means that this value of x is rejected. Okay? So our conclusion, x is equal to 4. This one is rejected because it is not an integer. Very, very important. Every aspect in the question is very, very important. We must be very, very careful. I want to repeat. Here we talk of 3 consecutive terms and not the first, second, third term. Here we say x is an integer. So when we solve like that, we should always keep in mind everything written in the question. Now, this is the value of x. So we have solved the first part of our question, which is the value of x. The value of x is 4. Now, the second part says find the common ratio. How do we get the common ratio? The common ratio is given by any higher term divided by the term immediately preceding it. So we can take this all over this, or we can take this divided by that. We will have the same value. So here we'll say x plus 2 all over 4x minus 4. Alright? That should give us, we know the value of x is 4. And here we have 4 into 4 minus 4. That gives us 6 all over 4 multiplied to 4 is 16 minus 4. So we have 6 all over 12, which is a half. So our common ratio is a half. Our common ratio is a half. That is it. We got the solution for B. Now the question says, given that the fourth term of the progression is 3, all right? What is the general term for a GP? There's an expression for the general term. We'll call the general term Tn. That the expression for the general term is always a r to the n minus 1, where a is our first term. We can also write this as T1, where a is our first term. So now we are told that the fourth term, T4, is 3. What does that mean? That means 3 is equal to our first term, which we don't know. We know our common ratio, which is r, and then we'll have 4 minus 1. So we're saying 3 is equal to first term multiplied to a half to the power 3. This expression here will help us calculate the first term. Look at it. We have to find the first term. This expression here, the only unknown is our first term. So when we get a, it means we are gotten the first term. Alright, what is a half raised to the power 3? So we are saying 3 is equal to a into 1 to the power 3 is 1, 2 to the power 3 is 8. Alright? This is the same thing as saying 3 is equal to a all over 8. Now, this is a fraction. We can always make this a fraction so that we cross multiply. 8 multiplied to 3 is equal to 1 multiplied to a. And so, you see the value of a is 24. So, our first term is 24. Alright? So, we found the answer to question C. Our first term is 24. Now, the last part of this question says we should find the sum to infinity. The sum to infinity. What is the sum to infinity? Sum to infinity. There is an expression for it. We write it as such. And there is a formula. Sum to infinity is always the first term all over 1 minus the common ratio. That's the formula for sum to infinity. Now we know our first term. Our first term is 24. And we know our common ratio, a half. So this gives us 24. All over 1 minus a half is a half. All right. So this one, what do we have here? 24 divided by a half. This is a fraction. We can always make this a fraction. So we'll maintain the first fraction, change this to multiplication, and invert that one. And so our sum to infinity will just be 48. All right.